To introduce the binomial theorem, we need some new notation first. So n over r inside parentheses is read n choose r, and this is going to be nothing more than the same thing as c n r. So this is just a combination. As an example, 4 choose 3 is just going to be c 4 3, which is p 4 3 over 3 factorial. So that's 4 times 3 times 2, all divided by 3 factorial, which is 4. The binomial theorem is going to give us a way to expand x plus y raised to the nth power. All the powers of the exponents add up to the same thing that the original power was, and the chooses, the combinations in front, follow the powers of the y. As an example of how this works, let's take a look at the familiar x plus y raised to the second power. We're going to write this down. This is 2 choose 0 times x raised to the second plus 2 choose 1 times x raised to the 2 minus 1 times y raised to the first plus 2 choose 2 times y raised to the second. If you do all these chooses, 2 choose 0 is 1, 2 choose 1 is 2, and 2 choose 2 is 1 again. So x squared plus 2xy plus y squared. Do the same thing for the cube, and we get 3 choose 0 x cubed plus 3 choose 1 x squared y plus 3 choose 2 x times y squared plus 3 choose 3 times y cubed. If you actually do all of these combinations, x cubed plus 3x squared y plus 3xy squared plus y cubed. Why does this work? If we take a look at a particular example, x plus y squared, then you know that this is nothing more than x plus y times x plus y. If we multiply this completely out, this is going to be x times x plus x times y, looking at the outer two, plus y times x, looking at the inner two, plus y times y. You might notice that this is just all the different ways we can take the letters x and y, two at a time, and arrange them. Now, of course, we can combine two of these terms together because we know how multiplication works. In particular, if we have the same number of y's in our two terms, or the same number of x's, we can combine them together. What we're looking for then is how many ways can these be combined so that they have the same number of x's or y's? Or in other words, how many of these terms are going to have that many y's? In this case, we have only three choices, 0, 1, or 2 y's, and there's 2 choose 0, 2 choose 1, 2 choose 2 ways of doing each of those, which is why we get these terms in the binomial theorem. To see how this actually applies, let's say I have 7 CDs, and I want to know how many ways I can choose some of them to take with me on a trip. Well, I can list all the different possibilities. I have 0 through 7 CDs, and I can look at the number of ways I can take each of those numbers. So 7 choose 0, 7 choose 1, 7 choose 2, and so on. Each of those for a certain number of CDs. Then my total number of ways I can take a certain number of CDs is just going to be the sum of all of those. 7 choose 0 plus 7 choose 1 plus and so on. If you look at this closely, this is very similar to the right-hand side of the binomial theorem. If we take n equal to 7 and we get rid of all the x's and y's, that's exactly what we have. Just the sum of a bunch of combinations. So how do we get rid of the x's and the y's? Well, the easiest way is to write both of them as 1. And so all these things added together is just going to be 1 plus 1 raised to the 7th power. That's the binomial theorem. So in other words, we get 2 to the 7th, or 128 different ways of doing this. Now you could add all those up if you wanted, but this is much faster. Now what if I want to bring at least 2 CDs? Then I'm not going to look at all of the terms, I'm just going to look at some of them. In particular, I'm going to look at the last 6 here. So how do I get rid of those first 2 terms? Easy, I just subtract them to the other side. 2 to the 7th minus 7 choose 0 minus 7 choose 1 is going to be all of those other terms added together. And so this is the number we're looking for. Calculate this out and you end up with 120.